high voltage caps. They've all four been replaced. You can see the solder connections there. Got sprigs in there. Selenium rectifier. Hello again, everyone. Welcome back to the basement shop. It's time for another vintage TV restoration. So let's get started. Teletone model TV-220, 7-inch electrostatic set. This is a split chassis, has a cable that plugs in from one chassis to the other. Other than that, not a lot different than a typical 7-inch electrostatic set. There's a look at the front. All the original knobs still there. They all seem to be working. On and off volume. Contrast, brightness, vertical, horizontal, channel changer, fine tuning. We did a previous video on this when I first got the set. Just done quick analysis. We determined the picture tube does test really good on a working chassis. Vinyl covering and just a few minor scratches. Yeah, we need a handle. Antenna's still good. This has a ribbon style antenna that just pulls out and it supports itself. Then when you're finished, slide it back in. And it does rotate so you can get the best picture. We got one catch broken here, so we'll have to figure out something on that. So to get started, first step is disassembly. We have 4 screws that hold the back on. Get that out of the way. We'll pull the knobs off. And the chassis has screws here and some in the bottom for the lower chassis. Fine thread screw with a decorative washer. And the cord is hardwired into the chassis, so we need to get it unwrapped. Tube layout chart. This was laying inside, so we'll definitely try to re-glue that. Might make a copy of it and put a new one in it. We'll see how that works out. That's later on, of course. Here's a cable that plugs between the two chassis. So, kind of an oddball there. It's a 12-pin octal type cable. And the tube is mounted to this chassis, the picture tube, so we need to pull all of this out at one time. I think if we take the lower chassis out first, leave the antenna where it's at, and we'll disconnect it. There's the 2 wires going to it. Pull the knobs off. And we have some 5/16 bolts and washers. One missing, but 5/16. We have a couple of cables that plug in from the other chassis. All right, let's take a little closer look at this. Get this cabinet out of the way. The first thing that grabs my attention, Teletone, Teletone, Teletone. Raytheon, Teletone. I think that's a Teletone. We do have 2 tuner tubes missing. The lid on the high voltage section is loose. Some screws missing, so take this screw out, the one that's holding it. Let's take a look inside. Other than the transformer being loose, I think it's connected. Looks like it is. So we'll need to fasten that back, secure it. Put that back on. There's a gigantic speaker. It's like a 4-inch speaker. Just a lot of dust. Let's look underneath. Not a lot of paper caps. As you can see, there's maybe half a dozen. Looking around for work that's been done, and a little bit of work right there on that filter cap. It looks like maybe it's been changed because you see that red wire or the orange wire, like it's been cut and reattached. So I'd say that filter cap's been changed. This switch, I think that's supposed to be straight, and it's bent. There we go. It's an AC interlock switch. The back pushes up against it when you put the back on. No shield on the tuner, pretty typical. What that jack is for, we'll have to investigate that. I'm not sure. Okay, let's we'll set this aside, pull out the other chassis. We'll have to be careful with this chassis because the picture tube's attached, and it's way up. Here's the bottom of it, so we need to support it. Okay. There's those 2 wires we had to unplug from the other chassis. There's where that interconnect plug goes. Brands of tubes here. It's an RCA. Raytheon. There's a Teletone. Most likely original. Another Teletone. And a GE. So, quickly look here, see if we have any kind of code numbers. 9-39, 1949, 39th week. Most likely original. And that's 39, 26th week. Seven JP4. It's a Hytron. And this was replaced April 1953. So that may explain why the tube is bright and had a really nice picture on it. Probably wasn't used much after it was replaced. What do we got going on underneath here? Definitely been high voltage caps. They've all 4 been replaced. You can see the solder connections there. They're sprigs. I'd say these have been replaced. You can tell by the way they've been jumpered in, and I think are the wrong color too. That's probably original. That's probably original. That one. That one. Selenium rectifier. That fusistor. And there's a filter cap. It doesn't look like it's had anything done to it. It looks original with the wrap there and the solder connection. And here's some insulation material here. Kind of a phenolic sheet underneath these controls, which have high voltage on them, so that's understandable. Insulated from the chassis. Back up on top, there's another filter cap there. Certainly looks original. Before I set this chassis aside, we'll take this picture tube out, store it in a safe place, and we'll just be using a little test tube when we work on this. 1/4-inch nuts here on the bracket, and just loosened it. I'm not taking it all the way off because I think I can just pull it out. Okay, mounted a little 3-inch test tube. Tighten the clamp down so that's stable. So where do we start? Well, let's try to make this video interesting. We'll get off to a running start here. I'm going to do a power up. Now, this is series wired. The tubes are, so I did have to populate these two missing tubes. This is a 6AG5, 6J6. So we have all the tubes in now. I'm plugged up between the chassis. So let's just see what happens. Of course, we can do this safely because we have the Syncor Powerite. Okay, this is a power switch and it's turned off. So we're going to run the Powerite up to about 70 volts. And then we're going to put it on current. Let's turn it on and see what the current meter does. We're not drawing much current, but the tubes have to light up and start to conduct before we'll see much current draw. That one's lit up. Not sure about these. That one is. But I don't think these are. Don't hear any sound, any popping or anything. Well, that wasn't very exciting, was it? I think there's 4 tubes that look like they're lit. So let's look at the schematic here real quick, and just to see how these tubes are wired. Filaments. We're coming directly in. Going across here. That's that 12-pin plug. And it picks up again down here. So we have V16 and V17. They complete the circuit to this pin, which goes back up here to this pin and on to these other tubes. A couple of things could be wrong. We could have a tube with an open filament. We could have tubes that aren't installed correctly. You know, wrong tube in the wrong socket. Or we could have a wiring problem between this pin and where it comes back out here goes back up to the rest of the tubes. I'm using the Sam's Photofact. And I have a riders that I printed out, but it's just basic stuff. I think there's a schematic here, but it is so small. Yeah, see, it'd be hard to read. So that's why I like the Sam's. So anyway, let's see if we can figure out why these tubes aren't lighting up. After chasing all of these voltages on the filament pins of each tube, I had my voltage all the way down to pin 7 at V20. V20 is a 25Z6 rectifier. And we got an 18 ohm resistor that connects to pin 7, goes back to the rectifier, and back this way too, to a couple of tubes, and even back up into here. So this resistor right here is at 18 ohm, connects to pin 7 of the rectifier, low voltage rectifier, and goes up to the selenium rectifier, and pin 8 of V17, which is a horizontal lamp tube. So in other words, it's in the filament string. With that bad, we're not completing the filament circuit. It checks 250 ohms, it's supposed to be 18. So I just bridged in a 15 ohm, 5 watt. Now all the tubes lighting up. We'll let it warm up a little. We're drawing about 0.6 of an amp. That's 0.7, 0.5. Run it on up to 100 volts. And closer to 3/4 of an amp. CRT, nothing on it. I don't hear any sound. But at least all the tubes are lighting up. I don't want to play this too long. That old selenium rectifier may go up in smoke, and we don't want that. That's an awful odor if that happens. So I'm going to turn it off. That resistor connection that's open or increased in value goes directly to the rectifier, and then we have an 18 ohm coming out to pin 3 of the low voltage rectifier tube. That bird right there, so he may be open too. Let's check it real quick before we dive into other things. Reading 470,000. I don't think that's right when it's supposed to be 18 ohms. So I'll tell you what I'm going to do. I'm going to put a silicon rectifier, eliminate this. We'll put a silicon rectifier on the incoming pin and attach it to this connection here through an 18 ohm resistor. See if we get anything. Okay. Incoming AC to the rectifier, the anode side. Cathode side comes out to a 15 ohm resistor, which connects here. Meter connected to the cathode side of the rectifier. $112. Definitely have something going on out of the speaker now. let me check and see if we have any high voltage on those high voltage caps. And nothing. But we do have some DC voltage. And we have some sound. I just clipped a test lead on my antenna terminal. It's picking up the signal on the blonder tongue modulator. That's channel 6. Tuner connection's dirty. Volume control connection's dirty. But without doing very much, a couple 18 ohm resistors. That selenium may work if I just clip the resistor in, but I don't want to take a chance on that thing burning up. But just a little bit of work there. We have sound. So that's pretty encouraging. Because this is a two-piece chassis and we have this cable between these connections here, a plug and a jack, this circuit's just a little more complicated to figure out. But now that we have all the tubes lighting up, had a little bit of sound on the set, we know this is okay. We'll start here in the power supply. We'll get it working and then continue on. Replace the two 18 ohm resistors. This was one in the filament string, R88. And then I removed the selenium rectifier, used a terminal strip, silicon rectifier out of it over to this point, and I used two 10 ohms, which gives us approximately 20 ohms on that one. The power supply is working, but you'll notice I have this connection, this wire unhooked. It goes to that 12-pin jack that connects to the other chassis with that cable. And it's drawing quite a bit of current. When I hook that up, this is a 680 ohm resistor, and this baby starts to get pretty warm and hot after just a minute or two. And that's this resistor right here, at 680. And if we trace this down, this goes back up to that jack, like I said, comes back out, up to here, into the high voltage oscillator. Now this is that circuit board, or that circuit that's on the other chassis under the shield. We have a 25L6 and we have a 1B3 rectifier. So this is drawing a lot of current. I think my next step is the high voltage caps. These are always bad, so we're going to replace all 4 of them. We have 2 down here and 2 right here. So let's change those, see if it makes any difference on the current draw on this line. I've seen this a lot when these high voltage caps have been replaced. Now these are in the vertical circuit. .005. That's correct. If we look at the vertical, 0.005. So these are correct, but look at these. These are supposed to be 0.0005, and they put the same ones. I'd have to decipher that color code there, but same one as what they put in the vertical right here. That's not correct. And they would work Your picture might be out of proportion, but it would produce a picture. So let's get these put in. I have 3 of the 4 installed, but before I take this one out, look at those connections. Not the best soldering job I've ever seen. Okay, just some temporary connections. See if we made any difference. Well, that didn't help at all. And we're still got a massive voltage drop across this resistor. We got approximately 200 volts on this side and about 120 on this side, and she's getting pretty toasty. So that leads us to this circuit, a high voltage oscillator. And if we look at it here on the schematic, we've got a couple of high voltage caps right here. Of course, 2 tubes in the transformer. So we need to tackle that circuit next. So that's going to wrap up part 1, 1949 Teletone model TV-220. Next time we'll tackle the high voltage circuit. Thanks for watching. Hope you've enjoyed the video. If you did, give us a like, comment, and subscribe to our channel. See you next time.